Agent Observability, Playlist 4, Episode 5. Status codes lie, traces don't. Here's the moment every agent team has lived through. The dashboard is green, the LLM call returned to 200, the tool executed without error, the response was delivered in 2.4 seconds, every metric healthy, and the user is staring at output that is completely, confidently wrong. Without observability, you guess. With observability, you open a trace. The two outcomes are not the same job. Here's the core problem. Agents fail in ways that look like success. Traditional logging tells you whether requests succeeded, whether status codes were 200, whether latency stayed in budget. All true, all passing. None of it tells you whether the agent did the right thing. A model can return a well-formed answer that's completely wrong. A tool can execute successfully with the wrong arguments. A handoff can pass corrupted state, and both sides report success. Said again, because it matters. Success and correctness are not the same thing in agent systems. Status codes lie. The trace is the only thing that tells the truth about what actually happened. Part 2, what to actually trace, 4 layers, 1 standard. Here's the part that's new in 2026. The field converged on a standard, OpenTelemetry GenAI Semantic Conventions, developed by the OpenTelemetry GenAI Special Interest Group since April 2024. Client spans are stabilizing. The conventions are still maturing towards stable. Datadog, Honeycomb, New Relic, Grafana support it natively. LangChain, Crew AI, the OpenAI Agents SDK emit OTel-compliant spans. Same names, every backend, every framework. Here's what a well-instrumented agent trace looks like. Top of the tree, the invoke agent span, the root, 25 seconds. Underneath, nested children, the LLM call, the tool executions, the handoff to a subagent with that subagent's own nested spans inside. 4 layers of spans, LLM client, agent invocation, tool execution, workflow, and handoffs. All 4 required, all 4 labeled with the same OTel vocabulary. 4 layers, 1 standard vocabulary, 1 queryable tree per agent run. That's the foundation. Most teams stop at instrumenting LLM calls, and that's why they can't debug. Here's the rule that separates teams who debug from teams who guess. The most informative span is almost never the LLM call. The LLM call almost always succeeds. The bug lives in the handoff between nodes, where one agent passed bad state to another. It lives in tool I/O, what arguments the tool got, what it returned. It lives in state mutations, the change that happened just before the wrong answer. Hold this. Instrument the handoffs, not just the LLM call. The handoff between agents, the tool inputs and outputs, the state mutations, that's where you find what went wrong. And the philosophy, log 100% of errors, sample successes. Trace handoffs, tool I/O, state mutations, not just LLM calls. That's the difference between an observability stack that helps you ship and one that just produces graphs. One production detail. By default, OTel GenAI conventions allow capturing message content, prompts, and completions in trace events. In production, you don't want that. Set the capture message content flag to false at the SDK. Use the collector's redaction processor as a second layer. Lock down trace backend access as a third, 3 layers, because each will fail at least once. Remember 3 things. Agents fail in ways that look like success. Green dashboards don't mean correct outputs. OpenTelemetry GenAI semantic conventions are the 2026 vendor-neutral standard, 4 layers, 1 vocabulary. And the high-value spans are handoffs, tool I/O, and state mutations, not LLM calls. Instrument those and you debug. Skip those and you guess. Instrument the handoffs. That's where the truth lives. Next episode, Harness Engineering. Subscribe.